So this is moving at 25 meters per second, whereas this is also moving at 20 meters per second. Now, they moved after collision, okay? The two masses respectively collided, and after collision, they moved together. So they moved together after collision. Find their common velocities if they were moving I in the same direction and I in opposite direction before the collision. And it's a Wayek-Wasi question. Okay, so if they collided and after collision, okay, they moved together with a common velocity, then Nana, what kind of collision is this? Nana, if they move together and joined and move with a common velocity after collision, then what kind of collision is this, Nana? Oh, Nana, you were not around when we treated this.
No, please, I don't think so.
Okay. Then Ekuyadoma, if they joined and then moved with a common velocity after collision, then Ekuya, what kind of collision is this? Ekuya, don't waste time. What kind of collision is this? If they joined and then moved with a common velocity. All right, anybody else? Time's sake. Anybody else? If you are ready, just answer and let's move on.
Sir, please, is it perfectly elastic collision?
Come again.
Is it perfectly elastic collision?
The two bodies joined after collision.
Perfectly inelastic.
Perfectly inelastic collision, where the coefficient of restitution is equal to what? Is equal to?
Zero.
Is equal to 0. You see, if you use the coefficient of restitution formula, V2 minus V1 on U1 minus U2. If it's a perfectly inelastic collision, E is equal to 0. So if E is equal to 0, you realize that 0 will be equal to V2 minus V1 on U1 minus U2. When you cross multiply, you have V2 minus V1 equal to 0. So V2 will be equal to V1. So for perfectly inelastic collision, the final velocity of the masses, okay, are equal. All right. So let's look at our question. So we are to find the common velocity if one, they are moving in the same direction. So moving in the same direction. Before, let me check attendance. I have 17. Okay, more should come. So this is M1 moving with a velocity of 25 meters per second. They are moving in the same direction, so plus M2 moving with a velocity of 20 meters per second. After collision, the two masses join M2 and their velocities are the same. V1 is equal to V2, so they are all moving with a common velocity V. So M1 times U1 plus M2 times U2 is equal to M1 plus M2 times a common velocity V. So we are saying that let their common velocity be equal to V. So substitute values of the masses 20 by 25 plus 15 by 20 is equal to 20 plus 15 all times V. Okay, this is 500 plus this is 300 is equal to 35V. Therefore, 35V is equal to 800. And please, when I was marking your work, some of you, I didn't see that methodical step-by-step solution. This is how you must do it. Okay, so you give a preamble that lets their common velocities or let their common velocity be V, so that whoever sees V can relate then that this is their common velocity. So V therefore, hello.
Please,
Hello,
can
see?
you do the drawing instead of writing the let the common velocity blah blah blah?
Can
Use the
you
drawing? Can you use the simple kind of like drawing illustration to represent that instead of writing the let the velocity blah 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 thing?
Oh, you can. And you can do it. And when you also understand that drawing is not necessary. Okay.
Okay,
Mm.
thank you very much.
All right. So you have 800 on 35. And what is 800 divided by 35? Yes. I'ma hurry up. I'ma Racy and the rest of you hurry up. 800 divided by
22.86.
52.
22.86.
Meter per second. Let me drop the attendance. Thank you. I'm coming. Let me quickly drop the attendance. that the attendance really helps. If you don't come, your parents will just beat you, so you join us. Mhm. All right. So your step-by-step application, very, very important. Or solution. Rachel, mute yourself. Okay. Then if they are moving in the opposite direction, if they are moving in the opposite direction, all that changes is that one of the masses has a velocity opposite to one of them. So M1, U1, M2, U2. And after collision, since it's perfectly inelastic, they still combine and move with a common velocity. Now, I'll subtract the momentum of 2 from the momentum of 1. The reason is that momentum of 1 is greater than the momentum of 2. So if it's the other way around, then I'll take momentum of 2 and subtract momentum of 1 from it. So M1 U1 minus M2 U2 must be equal to M1 plus this times V. When you put in your values, you have 20, we've just already calculated for this. So 500 minus 300 is equal to 35V. Therefore, we have 35V is equal to 200. V is 200 divided by 35. And what is 200 divided by 35? Amma, Eresi and Co. Over to you.
5.71.
Okay, so 5.71 meter per second. So a very simple. And momentum, you also treat this in EMAT. You'll be doing the same thing, elastic and inelastic, but they will add directions when they are moving at a particular direction, and after collision, what will be their direction, calculate. So you treat the same thing and in elective math as well. Please, any question? All right. If no question, in fact, I gave you another question. I mean, this one, and only a handful of you tested it. I just posted it on the platform. And these are questions for me when you manage to try. In fact, it really opens your conceptual understanding so much because a lot of it goes into it. Let's quickly look at that and then come to what we want to begin with for the week. Only a few of you sent the solution of this question to me. Alvina, you did. Amma, you did. Who else? Who else? Adwa, Otubia, you also did. The rest are still resting with it. Please, I forwarded the question onto the page, so check it and let's begin. Question 1. Two masses, 1 gram and 4 gram, are moving with equal kinetic energies. I think Adwa, Equia, are you there? Adoma? Equia, Adoma, are you there? Yo. So, two masses, 1 gram, M1 is equal to 1.0 gram. Then M2 is also equal to 4.0 gram. They are moving with equal kinetic energies. So it means that kinetic energy of 1 is equal to the kinetic energy of 2. They are moving with equal kinetic energies. The ratio of the magnitudes of their linear momenta. So they are looking for the ratio of their individual momenta. Okay. So P1 over P2 would give us the ratio of. So all that we are saying is that let the momentum of 1 be P1, let the momentum of 2 be P2. So to get this, let us look at the relationship between momentum and kinetic energy and mass. There are two relations. Kinetic energy half mv squared. Momentum P is equal to mv. If you make m the subject and substitute into this relation, you have one formula. If you make v the subject, you have another formula. So there are two possible equations connecting kinetic energy to momentum. Let's make m the subject and you have p on v. So you have k is equal to half p v. With this, so this is one equation connecting kinetic energy, momentum, and mass, and velocity. K is directly proportional to momentum. K is directly proportional to velocity. Here, we can use this because we are given masses. We are not given velocity. So we can use this particular equation. Class, are you there?
Yes, please.
Then let's make V the subject. V is equal to P on M and substitute into the kinetic energy equation. So K is equal to half M times P on V squared. We have half M times P squared over V squared. Okay, this hold on. Oh, some more over M. So over M squared. So we have P squared over 2M as another relationship between kinetic energy and momentum. And we can use this because we're giving masses. M, we have M here. We are told that they have equal kinetic energy. And so we can find momentum. Please, are you okay with the second formula? Are we okay?
Yes.
Okay, since we are looking for ratio of their linear momenta, let's make P the subject. P squared is equal to 2mk, meaning P is equal to square root of 2mk1. Sorry, K. So if we are looking for the momentum of one, which is P1, P1 will be equal to square root of 2m1 k1. Let's substitute m. M1 is 1 gram, so we have 2 k1. So P1 is equal to square root of 2 k1. Let's then look for P2. P2 is equal to the square root of 2m2 times k2. P2 therefore is equal to the square root of 2 times m2. M2 is 4 gram times k2. So square root of 8 k2. So let's take a ratio of the momentum of 1, momentum of 2, and find their ratio. So P1 on P2 is equal to root of 2k1 over root of 8k2. And this is equal to root of 2k1 all on 8k2. This is 1, this is 4. Earlier, we were told that they have equal kinetic energies. So K1 is equal to K2. Therefore, this and this will cancel out. So the ratio P1 on P2 is equal to square root of 1 on 4, which is the same as 1 on root of 4, 1 on 2. So P1 is to P2 is equal to 1:2. In fact, because I'm teaching, that is why this looks lengthy. But if you are doing it within 1 or 2 minutes, you can get your answer and then move on. But this is how it must be done. So the ratio of their linear momenta for the two masses is 1:2. Please, are you okay?
Yes,
Are we okay?
please.
The rest of you, are you okay? All right.
Yes. Please.
Silence. Hello, if you have any question.
So say,
Already.
please, does that mean that like the general formula to like find it is P2 is equal to root 2M2K2, root 2MK2?
The general formula connecting momentum and kinetic energy is this. Oh,
P is equal
okay.
to 2MK2.
Or it can also be this. It can also be this one. We didn't use K is equal to PV on 2 because we're given masses. In this equation, there is no mass. We have kinetic energy, momentum, and velocity. There's no mass. If we had been given velocity and then find the ratio of the momentum, then we would have used this. Eresi, are you okay?
Yes, sir.
So there are two equations for kinetic energy and momentum. You look at what you are given and decide on the appropriate equation to use. All right. Then the second question. A bullet of mass 10 grams hits a target and penetrates 2 centimeters into it. If the average resistance offered by the target is 100, then the velocity with which the bullet hits the target is, so we are looking for the initial velocity. As for the final velocity, is 0 because when a bullet hits a target, the target would resist it and then reduce its velocity to 0. No bullet upon hitting a target goes forever. It has to come to a stop. So the final velocity V will certainly be 0. But what is the initial velocity? So over here, let's extract our values. We are told that the mass is 10 grams. The mass of the bullet is 10 grams and hits a target and then penetrates 2 centimeters into it. So the distance traveled by the bullet is 2 centimeters. The average resistance offered by the bullet is 100 Newton. Then the velocity with which the target hits, the bullet hits the target, initial velocity, is U. Since the target resists the bullet, the final velocity must be 0. So how do we determine the final velocity? The initial velocity. When we use this, V squared is equal to U squared plus 2AS. We must be able to determine U. Meaning we will need A, we have V is 0. We will need acceleration. S is given to us as 2 centimeters. So how do we get the acceleration? Force is equal to mass times acceleration. Okay. Now, what is the force? The force must be the net force. It must be the net force, but we were not given the force with which the bullet hits the target with. We were only given the resistance produced by the target. So assuming the marker is the bullet, okay, it goes with some force and the force is resisted. We were not given this. Meanwhile, we're given the resistance. So we use the resistive force as a net force. Okay, we use the resistive force of 100 Newton as a net force. So 100, okay, 100, and this is a resistive force. What I mean is that I have to go here and you are also resisting me. There's something which is also resisting me. So the direction of this and this opposes. And so the resistive force is a negative. So negative of the 100 Newton times the mass of the bullet. The mass of the bullet is 10 grams. Change, this is in Newton. So change the 10 grams into kilogram by dividing through by what? 1,000. Okay, so we have 10 to the power negative 2 because this will be 10 divided by 1,000 to give us that times A. So we have A giving us minus 100 divided by 10 to the power negative 2, which will give us 10 to the power 4. Negative 1 times 10 to the power 4 meter per second squared, but a negative value because of the resistive force minus 100 Newton. Or let me take it differently. This will give us 0.01 times A. And so A is equal to minus 100 divided by 0.01. And this must give us 10, negative 10 times 10 to the power negative 4 meter per second squared. Please, are we okay? Are we fine?
Yes, please.
Then we are looking for U. So when we make U the subject here, we have U squared is equal to V squared minus 2AS. V is 0. The final velocity is 0. Minus 2 times the acceleration is negative 10 to the power 4. Negative 10 to the power negative 4 times the distance, 2 centimeters. 2 centimeters is 0.02. So we have 2 times 10 to the power minus 4 divided by 0.02. Please calculate it for me. Or please divide 100 by 0.01. Let me see what that will give you rather. 100 divided by 0.01.
10,000.
Oh, okay. If it's 10,000, then I think we made a mistake here. This should be minus 10 to the power 4 rather, meter per second. And so this should be, so we have 2 times 10 to the power 4 divided by 0.02. What did you get for that? 20,000 divided by 0.02.
1 million.
You had 1 million.
Yes, please.
So U squared is equal to 10. Oh, are you sure? 1 million exactly. Because
Yes,
this is 2 over 100. And so 2 times 10 to the power 4. Let me bring it here. U squared, we have 2 times 10 to the power 4. Hello?
Mr. Adria, please. I don't understand why you are dividing, because the U square is equal to 2 times A times X.
Why?
But the formula as well as the last step you've given. I was saying when you made U square the subject, U square will be equal to negative 2AX. But I don't know, the last step you just explained, you were using the X to divide negative 2A.
You see, let's do it. What you see, this is giving us positive. This is 2, okay, times 10 to the power 4. This is 2 centimeter. 2 centimeter is 0.02.
Yes, please.
Okay, you had a question as to why. Oh, okay, I get you. I think I was changing it into set a, I think, fraction or so, but it has to multiply. So 20,000 times 10 times 0.02.
We'll give 400.
That's 400. Oh, okay. Thanks for the correction. So this is 400. So that when you take the square root of 400, you have 20 meters per second. Please let me make a quick call to school and then come back to you, okay? I just was called by the general office. Eric, good afternoon. If we look at the possible answers, I think the correct answer is C, 20 meters per second. Okay. Question 3. As for question 3, in fact, you can get the correct answer without calculating anything. A bullet, when fired at a fixed target, has its velocity decreased to 50%. Assuming my velocity is 10 meters per second, my starting velocity is 10 meters per second, and I'm told that the velocity is decreased to 50%, what will be left? If
5 meters per second.
Exactly, 5 meters per second. Okay, now listen. When fired at a target, a fixed target has its velocity decreased to 50% after penetrating 30 centimeters into the target. So after penetrating 30 centimeters, 30 meters into the target, its velocity is decreased to 50%. Now, the additional thickness it will penetrate before coming to rest. When it comes to rest, what has happened to the velocity?
Velocity is 0.
It's 0. So listen to that question. We have, when it went through 30 meters, its velocity is decreased to 50%. Now the additional thickness, it will penetrate before coming to rest is what will be the additional thickness? Okay, that's a velocity of 50% can penetrate before it comes to a stop or rest. Yes.
Is the question again?
Amma, go ahead. I'll come back to you.
Sir, please, I think they're asking for distance.
And so what will be the additional thickness? That it can move through before its velocity is 0. And that's the
I'll think
question.
about
I have seen another hand. If you want to contribute, please go ahead. What do you think will be the additional thickness? That the bullet, okay, can go within the target before it is brought to rest. Let me take the
Please 30.
15.
Obviously, it's 30 meters. Okay, it's 30. I take the question again. A bullet, when fired at a target, has its velocity decreased to 50%. Has its velocity decreased to 50% after penetrating 30 meters into the target. Okay, so if my velocity is 10, after going through 30 meters within the target, my velocity is reduced to 5. Now, how far can it go? Okay, before it is brought to a stop or rest. When it is brought to rest, its velocity is 0. What is the velocity left? The velocity left is half of the starting, so another 5 meters per second. So if for 5 meters per second, it could go 30 meters, then it can also use the remaining 5 meters per second to go the same distance, isn't it?
Yes,
So that's it. You don't need to sort of calculate to get this. It's just English. When you think through, you can easily get the answer. So it must be 30 meters again. Question 4. A car is moving on a straight road. Let me clean the board. Question 4, we have to calculate. A car is moving on a straight road with a speed V0. With a speed V0. If the coefficient of friction between the tires and the road is mu, the distance traveled by the car before it comes to rest is, so it is traveling with an initial velocity V0. If the coefficient of friction between the tires and the road is mu, so coefficient of friction is mu. The distance traveled by the car before it comes to a stop or to rest is, so we are looking for S. Meanwhile, the final velocity is 0 before coming to rest. So it means final velocity is 0. Initial velocity is this. Okay. Now, when a car is on a road, the external force acting on it is the frictional force. So, frictional force is the external force acting on it. And friction is given by mu, is given by mass, or frictional force is actually this. It's equal to mu mg. Newton is also saying that any force, whether friction or whatever, can be calculated by mass times acceleration. So the net force MA must be equated to frictional force because that's the external force acting on the body. And this would give us the acceleration of the body, which is mu mg over m. So the acceleration is actually mu g. But the question is this acceleration on the car positive or negative? Is the car accelerating or decelerating? Yes. Yes, I want your view. Is the car accelerating or decelerating?
Neither of them.
Lizzie, what do you think?
The body is accelerating.
Accelerating. Okay, more views.
Exactly, the body is decelerating.
Euresi, you are going for deceleration. More views. Lizzie, why accelerating? Euresi, when you finish, why decelerating? Euresi, Lizzie, why accelerating?
Mr. Dia, please, it's decelerating. It's decelerating because there's no velocity. So meaning the body will not accelerate.
Lizzie, we are told that the initial velocity is v naught. So to say there's no velocity, okay, Euresi, why deceleration?
So I think it's deceleration because we are putting friction into consideration here.
Any more view? Do we have any more views before I come in?
You say, yeah.
Amma,
Please, I also think it's deceleration
why?
because the question says, find the distance traveled by the car before it comes to rest. So like,
Exactly. So, class, it is a deceleration. This acceleration is minus because you are told that the body moves with the velocity v naught, and then friction opposes it till it comes to rest. When it comes to rest, the final velocity has decreased to what? Has decreased to what?
Zero.
Zero. So the velocity is dropping. When you have a larger velocity and it is decreasing, it's a deceleration. So this A is a minus because the motion was decelerating due to friction. Friction opposed the motion till its final velocity dropped to zero. And so this must be minus. Please, is it understood? Now, if this is the expression for A, then using V squared is equal to U squared plus 2AS. We are looking for S, the distance traveled. V is 0. U is what we are. U is given to us as V naught. And this is plus 2 times Acceleration is minus mu g. Then the distance is s. Let's make this the subject. So we have v naught minus 2 mu js. You are looking for s. So let's make s the subject. When you send this to the other side of the equation, you have 2 mu js is equal to v naught. Therefore, s equals v naught over 2 mu g, or half v naught mu g is the distance traveled. Charlotte,
Yes, please.
are you there?
Yes, please.
Inshira, I have about 3 insurers. Are you all here? Hey, none of the insurance is here.
Please, I'm
Everything
here.
is here.
Please,
Okay,
Hey, please, I'm here.
all right. So this is the value of the expression for the distance traveled. And I have the possible answers there. Clearly, is the answer A.
And say,
Hello.
please, why is it that since it's deceleration, why is it that it's not u squared minus 2as and it's plus 2as?
No, this is the general formula. This is the general formula before I substituted A. So in actual fact, if I'm to directly apply the negative to this must be minus. Minus, it should have been like this. But I was taking it gradually, that's why.
Oh, okay, thank you very much.
All right. Question 5. Question 5. A body of mass 5 kilograms, initially at rest, is moved by a distance of 2 Newton on a smooth horizontal surface. The work done by the force in 10 seconds is, okay, in fact, the work done in moving a body from one point to another point is the kinetic energy. Can I flip the screen if you are done writing? Yes. So if I'm to calculate for the work done is equal to kinetic energy. And I've proven this formula with you before. If this is a body over here, its initial velocity is 0. And it is moved to another point here. The distance is s. The time taken is t. So t, final velocity is v. When it goes to this point with the final velocity of v, initial velocity is 0. So as at when the body is being moved, was there an acceleration or deceleration? Yes, as at when the body is being moved from this point to this point, was there an acceleration or a deceleration? Hey, everybody is quiet. I've asked a question. Oh, we are moving a body from here to this point. Its initial velocity is 0, its final velocity is v. Was there an acceleration or deceleration?
Acceleration.
Good. There's an acceleration because the body starts with a velocity of 0. So if we are to calculate for the work done, hello.
So I want there to be a deceleration too because it started from 0 and ended with 0 again. So won't there be a deceleration too?
No, as at just before it stopped, we are looking at the velocity just before the movement stopped.
Okay.
The rest, are you okay?
Yes, sir.
So the work done, which is force times distance. What is the force? The force would be equal to the mass of the body times the acceleration. And the acceleration will be the final velocity minus the initial velocity, all divided by the time taken for this transition. So the force is equal to mv on t. What is the distance traveled? Using s is equal to ut plus half at squared. U is 0. So this goes to 0. 0. So straight away we have half at squared. Okay. Half at squared. Or if you are to use v squared is equal to u squared plus 2as. This is 0. And so the distance s will be equal to the final velocity squared divided by 2a. So let's rather use this. Because this can work, but we have to get another expression for a. Okay, you let me leave it and then we'll talk about it. So the work done is equal to the force is mvt. The distance is v squared over 2a. So we have half mv half t, half at mv cube. Let's get expression for a. Acceleration is equal to v on t. So when we substitute, let me adjust the screen. Let me clean the side of the board so we continue from this side. So we have work being equal to half at mv cube. We've had a to be equal to vt, v on t. So when we substitute into this equation, we have half mv cube. A is v, okay, v on t. There's another times t. So this is for a. All right. When we do that, we'll have t canceling out. And then w is equal to half v mv cube. V canceling this. So we have half mv squared to give us the expression for the work done. So the work done is actually equal to the kinetic energy. If you use S as this, and then you substitute into the same relation, this is what you have. Work is equal to force, which is mv on t times The distance is half AT squared. So you have one of the t's canceling out. So you have half MVAT. Now look at something. 80 A times T is actually this. When you make V the subject, you have AT. So we can substitute V for AT to be half MV times V to be half MV squared. All that I'm trying to say is that the work done in moving a body from one point, okay, a body of initial velocity 0 from one point to another point is the kinetic energy. So over here, all that you are looking for is the kinetic energy. Is the kinetic energy. Let me retrieve the question. All right. So a body of mass 5 kilograms initially at rest is moved by a force of 2 Newton on a smooth horizontal surface. The work done. So the work done is the kinetic energy. So KE is half mv squared. I have the mass. I need the velocity. Velocity squared is equal to 2as. What is okay, 2as. I have mass. I have the force. Okay, so if the force is 2 Newton, if the force is 2 Newton, then A will be equal to 2 on the mass, which is 5. And this is equal to 0.4 meter per second squared. Okay, what about the distance? What about the distance? So we need the velocity. Oh, okay, we need the velocity. So the velocity would require the acceleration which we have, and then the distance traveled. Distance traveled will be equal to half times the acceleration times the square of the time. So half by 0.4 times the time is 10 times squared. Calculate that for me. 50 times 0.4. What is 50 times 0.4? Or 0.2 times 100? That is what?
20.
So this is 20 meter. And so if the distance is 20 meter, then the velocity V will be equal to square root of 2 by 0.4 by 20. And that is
4 meters.
that is what? Multiply what's in the bracket for me.
12.65.
Okay. So
You get root of 160.
root of 160.
160.
Okay.
Yes.
So it
Which is
means, okay, go ahead.
which is equal to 4 root 10. And 4 root 10 is equal to 12.65.
So when you substitute it here, you have half times 5 times 12.65 squared. And you must get that for me. Hello? Good afternoon. I'm here to all. Figure for the kinetic energy.
31.625.
31.
Yes, please.
I think it must be 40.
Isn't that half times 5 times 12.65?
I'm coming.
Oh, that's
What's
not your calculation.
half times the mass is 5. The velocity is my concern. So check, let's see. Acceleration is 0.4. The distance is 20. So this is 40. Okay. 40 times 4 on 10. Oh, it must be, the velocity must be 4. Check the multiplication. This is what I'm saying. Look at it. We have root of, this is 40, 2 times 20, 40, times 0.4 is 4 on 10. Isn't it? And so if you have to, you have root of 16. And so root of 16 is 4 meters per second. Okay. So if V is 4, then we have half times 5 times 4 squared. 4 squared is 16. So 8 times 5 is 40. So please check your calculation. It must be 40 joules.
Mr. Yeah, even if
Hello.
you use the work done is equal to force times distance, the force is 2 and the distance is 20. So if you multiply, you get 40.
Yes. Yes. So the values you sometimes call for me. All right. Question 6. As for question 6, we've solved a similar one. 2 particles of masses m1 and m2 have equal kinetic energies. The ratio of their momenta is start work on this, and then tell me your answers. Here, I'm expecting almost all to get it right. Question 6. I'm leaving question 6 to you now. Solve it and then give me your final answer. It's similar to what we had in question 1. Are we through? Are we through with question 6? Yes, so if it's about let me get the hand. So this time, what do they have in common? They have the same equal kinetic energies. So if equal kinetic energies, then we have P, the momentum is equal to square root of 2mk. So we are looking at the ratio of their linear momentum. Okay, this time the masses are m1 and m2. So P1, the momentum one will be root of 2m1 k1. P2 is also root of 2m2 k2. When we take this, the ratio of their linear momenta, we have 2m1 k1 on 2m2 k2. Masses are different. Equal kinetic energy. So this and this, this and this. Therefore, root of m1 over root of m2, which is equal to root m1 is to root m2. Not so difficult, similar to what we've done before. Question 7. If the kinetic energy of a body is increased by 300%, Ke is increased by 300%. If I have an amount and it is increased for me, the increment is 300%. What will be the total amount obtained in terms of percentage? Yes. I have money and I have 300% increment on what I have. What is the total amount of money I have in terms of percentage? Class.
Mr. Bia, is the money you have times 30/100.
So if what I have is increased by 300%, what is the total amount I have in terms of percentage, Lizzie? That is Equia Adoma, Equia Charlotte and Co. Yes, talk to me.
100%.
What?
400%.
400%. Lizzie, what I have is intact, 100%. Okay, with what I have, it is expressed as a percentage, and this is 100%. If 50% is, if what I have decreases by 50%, then I have 50% being taken off my money. This time I have 400% being added. So, sorry, 300% being added. So all that I have is 400%. So K1.
Mr. Adria,
Hello.
please, I can't see your screen.
Hey, then Elvina, you must rejoin. Please, is it a common problem to all of us?
No, please.
So Elvina, rejoin. Okay.
Okay.
So if my initial amount, my initial kinetic energy, K, is K1. Okay. If we calculate 300% of this, of K1, this is equal to 3K1. You got 300%, 300 over 100, and it's equal to, so total, the new kinetic energy, K2, after the increment, after the 300% increment, will be equal to the initial K1 plus the change, 3K. So, you know, I have 4K1, and 4 is expressed as a percentage is 400%. So this is 400% K1. That's the new kinetic energy. Okay. So if I'm looking for the effect, what will be the effect? So the question is about if the kinetic energy of a body is increased by 300%, its momentum would increase by, okay, so a ratio of K1 on K2. Okay, but I know that kinetic energy relates with momentum by this formula. P is equal to root of 2m K1. So P1 will be equal to root of 2m K1, and K1 is 100%, just K1. P2 is equal to root of 2 is the same mass, but its kinetic energy is what is changing. So still m, but what is K2? K2 is now 4 times K1, 400%. So 4 times 4 K1. Therefore, I have root of 8 m K1 as P2. So let's take the ratio of their momenta and see how it will change. So P1 on P2, which is equal to root of 2mk1 over root of 8mk1. Therefore, P1 on P2 is equal to root of 2mk1 divided by 8mk2. This, sorry, K1. This and this will cancel. The same masses will cancel. And so this will be equal to root of 1 on 4, which is equal to 1 on root 4, so 1 on 2. Therefore, let's make P1, P2 the subject. We have P1 on P2 equal to 1 on 2. P2 therefore is equal to 2P1. Let's, Nanepia, go ahead with your question.
Mr. Eden, please, my question is about the one before this one. You see, with this one, you cancel the 2 and 2 out. So it means the coefficient of the M1 and the M2 is now 1.
Where? Here?
No, please. Up. On top of that one.
Over here.
Yes, please. Yes, please.
Oh, this is the first question I gave to you.
Yes, that one.
This is the square root of M1 over the square root of M2.
Mr. Eden, I'm saying that the coefficient is 1.
1, yes.
And root of 1 is the same one. So why is it not M1 is to M2 rather?
Why? No, you see, you have 1 times, this is what you have, 1 times M1. So you cannot just take, okay, square root of 1 and leave this. Square root of 1 is 1, but it is times root of M1.
Yes,
So
please.
it must strictly be root of M1 over root of M2. Are you okay?
Okay. Yes, please.
So over here, we have P2 to be equal to 2 times P1 and express 2 as a percentage. I want you to express 2 as a percentage. What would that be? Express the number 2 as a percentage. 1 is 100%. So 2 will be what? Oh, 2 is 200%. What it means is that if you increase kinetic energy by 300%, its momentum would increase by 200%. We increased kinetic energy by 300%. And when we went through, we realized that the new momentum will be two times the first momentum. And so the momentum is increased by 200%. Please, are we okay? Class, are we fine? Okay, question 8. I want you to try question 8 because it's similar to question 7. If the momentum of a body is increased by 50%, its kinetic energy would increase by what percentage? It's similar to question 7. Question 7, they ask us how the momentum would change when the kinetic energy increases. Over here, we are told that the momentum this time is increased by 50%. How will this affect its kinetic energy? So try it and then send it to me by WhatsApp before we all look at it. Are we through? Hello, are we through? So this time, we are told that the momentum is increased by 50%. So if P1 is P, then P2. So if the momentum is increased by 50%, what will be the new momentum? If P1 is P and it is increased by 50%, what will be the new momentum in terms of percentage? Yes.
Please, 150%.
Good. So this will be 150 of P, and 150% is 1.5 of the initial momentum P1. So the new momentum will be 1.5 or 150% of P1. Okay. So if the momentum of a body is increased by 50%, its kinetic energy would increase by what percentage? So using the relationship between kinetic energy and momentum, we have kinetic energy and momentum have, I think, 2mp squared. That's the relationship momentum has with kinetic energy. Okay. So if P1, P squared is equal to 2mk, and P is equal to root of 2mk1. So now we are looking at the effects on kinetic energy if momentum is increased by. So K1 is equal to P1 squared on 2m. K2 must be equal to P2 squared on 2m. It's the same mass. It's the same mass. So it is just the momentum that is being changed. So K2 will therefore be equal to P2, which is this, 1.5 P1 all squared divided by 2m. When we take the ratio of the kinetic energy, K1 on K2, we have K1 on K2. What is K1? K1 is this, P1 squared on 2m divided by, so times 2m over 1.5 P1 all squared. So that this and this, and we have P1 on 1.5 P1 all squared. We can put these two under the same umbrella, say they are all squared. So P1, we have K1 on K2 equal to 1 on, what is 1.5 squared? What is 1.5 squared?
2.25.
So this is 2.25. Therefore, when you make K2 the subject, you have 2.25 K1. And let's express 2.25 in decimal, as a percentage. 1, 2, you have 225 over 100 times K1. And so it means this is 225% of K2. Okay, so when you increase momentum by 150%, the kinetic energy would increase by, yes, when you increase momentum by 150, the kinetic energy would increase by what? 125%, because this is the final momentum. It means the kinetic energy, when the momentum is increased by 150, the increase in kinetic energy is 125%. There's 125% increment in the kinetic energy. So is the C, sorry, the B. Question 9 does not involve any calculation, so I'll leave that to you to think through. But question 10, two bodies of masses m and 4m. So we have two bodies of masses 4m and 4m are dropped from the top of a tower. So these two masses are dropped from the top of a tower. It means that the distance from the top of the tower to the ground for each one of them is the same. Let's assume this is the top of the tower. This is the ground. We have two masses on the top of the tower. This is M, 4M. This is the ground. So they have different masses, but their distance to the ground is the same. When they reach the ground, their kinetic energies will be in the ratio of, when they reach the ground, they will stop, they will be at rest. But here, such questions requires when they just hit the ground, what is their kinetic energies? Okay. It's not just when they hit the ground. When they hit the ground, they've come to a stop. So we are looking at the kinetic energy just before they hit the ground. The ratio of this. Kinetic energy is still half mv squared. Meaning, we'll need their masses and velocity. Now, when the body is dropping, here is a free falling situation. So in free falling, U is 0. So V will be equal to U squared plus 2AS. So the velocity of the first mass will be V squared square root of 2AS. Since it's free falling, this A is due to gravity, so J. Now, they are all dropped from the same height, tower. So S is the same for each one of them. So for V1, this is it. Root of the V squared. Let me even get the square out. V squared is actually 2JS. And the velocity will be the same for all of them because this velocity is about acceleration due to gravity and the height. And they are all falling from the same height. So V will be the same for all of them. Okay. So if you take it for K1, half M1, this same value. V squared is this. So V squared, let's maintain V squared instead of this, is this. If you take it for the second mass, K2, you have half M2 times the same value, so V squared. So a ratio of the kinetic energies would actually be equal to a ratio of their masses, because this is the same for all. The velocity is the same for all. What will be changing is M1 and M2. And so this will be equal to M over 4M, which is equal to 1/4, or 1:4, as the ratio of their kinetic energies. So that will be 1:4 for each one of them. Please. So this is all that goes into the questions I gave you. We are going to continue with, or begin with, light. Light is a broad topic. Okay, it's a broad topic. When you are able to cover light before you come to school, in fact, it will help us a lot, especially with practicals and all that. So our next area of call is on optics, geometric optics, what we often describe as light. So I think our time is fast spent. It's almost 3:50, and so we'll begin with light fully on Friday. Okay. And so let me use the time, okay, the few minutes left, to also conserve energy, since my voice is almost fading. So please, we'll begin with the main topic on Friday. Please take care of yourself, okay? And then please do not hesitate to solve questions. When you solve questions and you have difficulty, please be free and then WhatsApp it to me for any guidance, okay? Do not forget, because the more you solve questions, the better you become. So this is why I draw the curtain. We'll have another wonderful session on Friday. Take care of yourselves, and bye-bye to each one of you.
Bye-bye.
Okay.